A scene so chaotic, so impossible, that even the bravest engineers doubted they could survive it, let alone build anything on it. A world where rain fell in sheets so thick it turned the earth into soup, where mosquitoes swarmed like black smoke, and where every footstep sank in mud that clung like tar. It was the Pacific theater of World War II, a place where nature itself was the enemy. American aircraft, crucial for supplying troops, rescuing wounded soldiers, and launching counterattacks, needed one thing above all: airfields. But how do you build a runway on a swamp thousands of miles from home where every plank of wood rots, every steel beam rusts, and every minute lost means lives in danger? That was the nightmare U.S. Army engineers faced in 1942, a challenge so extreme it would spark one of the most ingenious inventions of the war: the Marston Mat, a simple sheet of perforated steel that could turn a jungle into an airbase in less than 2 days. The world would soon witness how brains and steel together could outmatch mud and chaos. But before that triumph came desperation. It began with a disaster at a place called Guadalcanal, where American forces struggled to hold a primitive airstrip hacked from the jungle, known as Henderson Field. Every night, torrential rains flooded the ground, swallowing trucks and supplies. Aircraft couldn't take off, and pilots cursed as their landing gear sank into the mire. Engineers tried everything: logs, gravel, palm fronds, even scrap metal, but the jungle always won. Planes that did manage to land kicked up waves of mud, spraying into engines, blinding gunners, corroding everything they touched. Commanders radioed Washington in panic. "We can't build airfields fast enough, and the ground eats everything." If America couldn't find a solution, its advance across the Pacific would die in the mud. The clock was ticking. In Alabama, far from the front lines, a group of engineers and metallurgists huddled in a small design lab, surrounded by piles of rusted steel sheets and mathematical charts. They were told only one thing by their superior officers: find a way to make runways that can follow the troops. These weren't combat men. They were problem solvers. Among them was Colonel James D. Marston, a brilliant but unassuming engineer whose name would later be immortalized in the invention he helped perfect. He looked at the challenge differently, not as a construction problem, but as a portability problem. The solution, he realized, wasn't to build better airfields. It was to make something that could become an airfield. What if, he proposed, a runway could be carried in pieces, lightweight, modular, easily joined together, and strong enough to bear the weight of a fully loaded bomber? The concept seemed insane at first. Steel was heavy, expensive, and prone to rust. Aluminum was lighter but scarce and strategic. Wood? Forget it. Termites and rot made it useless in the tropics. The engineers experimented endlessly, testing different alloys, perforations, and cross patterns, until one afternoon, a machinist pressed a flat sheet of pierced steel into a wave pattern using a giant hydraulic press. When they tested it, the sheet supported twice the weight expected. The corrugations gave it strength, the holes reduced weight and let water drain through. Someone remarked, "Looks like Swiss cheese on a washboard," and Marston smiled. That cheese board would soon cover thousands of miles of jungle. The prototype was called pierced steel planking, or PSP. Each section measured 10 feet long, 15 inches wide, and weighed about 66 pounds. That meant one man could carry it, two could lay it, and dozens could join thousands in hours. The holes weren't just for weight. They acted like teeth, gripping the ground beneath and locking with adjacent panels through a clever hook and slot design. The engineers didn't know it yet, but they had just created the world's first instant runway. When word reached the Pentagon, logistics officers were skeptical. Could such thin steel really handle a P-38 or B-25 landing on wet clay? Tests were ordered at Eglin Field, Florida, where torrential rains and soft ground mimicked the Pacific. Soldiers watched as engineers laid down a 150-foot strip in under 2 hours. Then came the test. A fully loaded bomber roared down the makeshift runway, and instead of sinking, the panels flexed gracefully, absorbing the impact. Dust rose, engines thundered, and when the plane took off safely, the crowd erupted. The brass was sold. Marston Mats were approved for mass production, but building them at scale was another war altogether. America's steel mills were already at full capacity, churning out tanks, ships, and weapons. The War Department issued urgent contracts to factories across the country, from Inland Steel to Pittsburgh Plate Glass, to produce millions of PSP panels. The assembly line thundered day and night, sparks flying as men and women, many of them new to factory work, welded, pressed, and perforated sheet after sheet. By 1943, production hit 2.2 million tons, enough steel to build 25 aircraft carriers, all flattened, punched, and corrugated into the lifeblood of Allied air mobility. Each bundle of Marston Mats was shipped across oceans in crates labeled Airfield Kit Portable. At the front lines, engineers would unpack them like puzzle pieces, hammer them together, and in hours transform muddy clearings into gleaming silver runways stretching half a mile or more. Pilots approaching from the sky said the sight of those shining mats glinting in the jungle sun was like seeing civilization appear out of nowhere. The true magic of the Marston Mat wasn't just in its design, it was in its adaptability. Soldiers used it not only for runways, but for roads, bridges, flooring, and even hospital bases. When tanks needed to cross swamps, engineers threw mats down like stepping stones. When planes needed emergency repairs, crews jacked them up using PSP as ramps. In New Guinea, where every airfield meant another foothold against Japan, engineers became known as the men who paved the sky. The jungles fought back, of course. In some places, the mats would sink overnight as the mud below shifted. Engineers learned to reinforce them with crushed coral or bamboo. In others, torrential rain would wash them away entirely, but they always rebuilt, faster each time. The record was set on an island in the Solomons, where a full runway was laid and ready for P-47 Thunderbolts in just 47 hours. Soldiers joked that the mats were like metal magic carpets. Meanwhile, enemy intelligence couldn't believe what they were seeing. Japanese reconnaissance pilots photographed new airfields appearing overnight and reported them as impossible illusions. Their analysts concluded that the Americans had found a way to dry the jungle overnight. They were half right. Engineers had simply learned how to outsmart nature. By mid-1944, Marston Mats had covered over 20,000 miles of Allied airstrips, from the Philippines to Burma, from India to the Pacific atolls. General Douglas MacArthur himself credited them for enabling his island-hopping strategy, allowing bombers to leapfrog across oceans, always landing on freshly minted steel runways. Without them, resupply, evacuation, and forward attacks would have been impossible. But even as these miracle mats turned swamps into strongholds, a new challenge loomed, one that would test not only the strength of steel, but the limits of human endurance. Deep in the jungles of Papua and the islands of Biak and Mindoro, engineers would soon face torrential rains, enemy snipers, malaria, and mud that swallowed bulldozers whole. It was there that the myth of the 48-hour runway would be born, a feat so astonishing that enemy soldiers refused to believe it wasn't sorcery. What they didn't know was that beneath every Marston Mat, beneath every bolt and hook, was a story of sweat, ingenuity, and courage, the kind that could turn a battlefield into an airfield before sunrise. The roar of engines echoing through a jungle still dripping with rain, the metallic clang of hammers striking steel in rhythmic urgency, and the shouts of exhausted men racing against an unseen clock. The sky is gray, the air heavy with humidity, and the ground beneath their boots sinks like sponge. Somewhere beyond the palm trees, a Japanese reconnaissance plane circles, watching in disbelief as the impossible begins to happen. An airfield, right there, materializing out of nothing. No blueprints, no cement, no time. Just steel panels, sweat, and sheer willpower. The men on the ground have a mission whispered in their ears by their commanding officer. We need this runway operational in 48 hours, or we die here. What happened next would become one of the most extraordinary engineering miracles of World War II, a feat that would etch the words Marston Mat into the annals of military legend. The story begins on a remote island in the Pacific called Biak, part of the New Guinea campaign of 1944. U.S. forces had landed under heavy resistance, fighting not only enemy fire but terrain that defied imagination. The Japanese defenders had carved tunnels into coral cliffs, emerging like ghosts at night to sabotage supplies. The Americans desperately needed an operational airstrip to bring in reinforcements and bombers. But the island's terrain offered no mercy, a mix of soft coral dust and swamp that turned to glue after every rainfall. When Colonel L.G. Haskins, commander of the 863rd Engineer Aviation Battalion, surveyed the site, his words were grim. You couldn't build a chicken coop here, let alone an airfield. And yet, within 2 days, his men would prove him wrong. They started at dawn. Bulldozers rumbled forward, their treads sinking knee-deep in mud. The drivers cursed, wiped sweat from their faces, and pushed on, carving a rough clearing from the jungle. Behind them, trucks unloaded crates stamped PSP, pierced steel planking. Each crate held hundreds of steel mats, dull gray and slick with tropical moisture. Soldiers ripped them open like lifelines. The engineers had done this before, but never under such pressure. The Japanese artillery was still within range, and every minute without air cover meant more casualties. Working in squads of 6, the men began laying mats side by side. They used sledgehammers to drive connecting hooks into place, each clang echoing through the trees like the ticking of a clock. "We're not building a runway," one soldier joked through clenched teeth. "We're building a miracle." They laid panels so fast that the men at the rear barely had time to hand up the next load. Every 50 feet, another squad followed, aligning, locking, and leveling. The heat was punishing. Steam rose from the steel like smoke. At one point, a tropical downpour turned the worksite into a shallow river, but the mats, riddled with holes, let the water drain away. It was as if they were made for this very hell. The design of the Marston mat made the impossible possible. Each interlocking section distributed pressure evenly, preventing the sinking that had plagued earlier attempts at building on soft soil. The engineers had learned to lay coconut logs beneath in high-risk areas, creating a floating base. The result was astonishing, a steel carpet that flexed, breathed, and held its ground, even as the mud below churned like lava. As one sergeant put it was like laying down a road that refused to drown. By nightfall, the first 1,000 feet were complete. Floodlights powered by portable generators bathed the clearing in white light, turning the jungle into a surreal construction zone. Men worked through the night, their shadows stretching across the mats like phantoms. Some had gone 20 hours without rest, hands blistered, uniforms soaked, but they refused to stop. "If we sleep, we die," one corporal said. At dawn, the first plane approached, a C-47 Dakota carrying fuel and ammunition. It circled low, the pilot radioing in disbelief. "You mean that thing's ready?" The ground crew waved their arms in the mist, signaling the all clear. The plane touched down, its wheels screeching over the steel planks, sparks flying from the friction, but it held. The crowd of engineers erupted in cheers. In less than 48 hours, a jungle that had been nothing but swamp now hosted an airfield ready for war. The news spread like wildfire through the Pacific Command. General George C. Kenney, commander of the Allied Air Forces in the Southwest Pacific, reportedly said, "Give me Marston Mats and engineers, and I'll build you an air force overnight." And he wasn't exaggerating. Across the islands, at Mindoro Lady and Saipan, similar miracles unfolded, each one faster than the last. Teams developed their own rhythms, bulldozers first, graders second, mat layers third, then rollers to press everything down. They timed themselves like a pit crew. The best units could lay a full 3,000-foot runway in under 36 hours if weather and supplies cooperated. What made the system revolutionary wasn't just speed, it was mobility. Once a runway was no longer needed, soldiers could unhook the mats, clean them, and ship them to the next island. One set of mats could serve 5, even 10 different airfields before war's end. The same steel that launched fighters over Biak could later anchor bombers at Okinawa. That reusability made the Marston mat not just a tool, but a strategic multiplier. But the miracle came at a cost. The 48-hour airfields were built not by machines, but by men. Men who worked through monsoons, under fire, often without sleep or food. They joked to keep spirits alive. "If you don't laugh, the jungle eats you," said one. They learned to hammer steel while crouched in foxholes, to drag mats through mud up to their waists, to drink from their helmets when canteens ran dry. For them, every clang of metal was a heartbeat, every completed strip a promise of survival. In some cases, Japanese forces would launch midnight raids to destroy the half-built airfields. At Aitape, engineers defended their worksite with rifles while laying mats in the dark. At dawn, when reinforcements finally arrived, they went right back to hammering as if nothing had happened. Their courage turned the simple act of construction into a form of combat engineering heroism seldom recognized in history books. Soon, 48 hours became more than an engineering record. It became a battle cry. Soldiers on transport ships would chant, "2 days to fly," as they neared new landing zones. The legend grew so large that even enemy propagandists began whispering of an American steel road that could appear overnight. But the jungle still had one more trick to play. In the coming months, as U.S. forces advanced toward the Philippines and the rains grew worse, engineers would discover that speed was not enough. Their mats would twist, buckle, and vanish under rivers of mud, unless they found a new secret buried deep beneath the surface of the islands themselves. What they uncovered would change not just how they built airfields, but how they understood the very earth they stood on. The story of the Marston Mat was only halfway told, and the next chapter would push engineering to its breaking point. Thunder cracked over the jungle like cannon fire. The monsoon had come again, drenching the new airfields that only days earlier gleamed silver in the sun. The engineers stared at what they thought were miracles now turning into traps. The very Marston Mats that had saved them were sinking into the mud as if swallowed by the earth itself. Planes that once landed smooth now jolted violently, tires tore holes through the planking, rivets snapped, and water bubbled up between the steel sheets like a living thing trying to breathe. Somewhere deep beneath those runways, the jungle was fighting back. The men didn't know it yet, but buried under every patch of ground they'd built on lay a secret. Not one of steel or sweat, but of the soil itself, a mystery that would change everything they thought they knew about building in the tropics. When the U.S. engineers reached the Philippines, they brought with them the pride of Biak, the 48-hour miracle. They were veterans of impossible construction, men who could make steel fly. But the Philippines weren't Biak. Here the rains didn't just fall. They possessed the earth. Torrents carved rivers overnight. Fields that looked solid in the morning turned into quicksand by dusk. And when the engineers laid their first Marston Mat runway near Tacloban, they watched in disbelief as whole sections vanished beneath the surface within hours. It wasn't sabotage. It wasn't mechanical failure. It was nature. Colonel James Marston himself, now assigned to oversee forward engineering operations, flew in to see the disaster. His transport plane circled the site 3 times before finding a dry enough strip to land. From above, he could see the pattern of failure. The outer edges of the runway sagged inward, as if something underneath had collapsed. When he stepped out, the air hit him like a wall, hot, wet, and heavy with the scent of rot. The men saluted him wearily. "Sir," one corporal said, "we've built 6 airstrips and buried 4. Marston knelt, scooped a handful of the reddish soil, and watched the water ooze between his fingers. It wasn't ordinary mud. It was laterite, a dense, iron-rich clay found throughout the tropics. When dry, it hardened like concrete, but once saturated, it turned to a viscous sludge that could swallow machinery whole. The engineers had unknowingly built on a foundation that could betray them at any moment. The steel mats, perfect on coral or sand, were helpless here. Every drop of rain turned the ground into a trap door. For days, Marston walked the ruined airfield, studying how the mats buckled and sank. He noticed something strange. In a few places where crushed coral had been dumped to level the surface, the mats still held firm. That was the clue he needed. He called an emergency meeting under a canvas tent lit by lanterns. "Gentlemen," he said, wiping mud from his boots, "our problem isn't steel, it's what's under it. We're not fighting rain. We're fighting the earth itself." That night, by flickering light and the distant rumble of thunder, they drafted a new plan. Instead of fighting the mud, they would use it. By layering local materials, coral, bamboo, palm fronds, even woven grass, they could create a breathing foundation, one that would distribute weight and let water escape naturally. It was primitive science meeting battlefield necessity. The next morning, the experiment began. Bulldozers scraped the ruined mats aside, revealing the soupy red earth beneath. Teams of Filipinos and American engineers worked side by side, hauling crushed coral from the nearby beach. Each truckload was spread, compacted, and topped with mats once again. The men held their breath as a P-38 Lightning roared in for a test landing. Its wheels touched down, bounced once, and rolled smooth. The airstrip held. Cheers erupted. The secret wasn't more steel. It was the right foundation beneath it. Marston's team documented every discovery, sketching diagrams and sending reports to headquarters. The result was a new doctrine: build from the earth up. Engineers were now instructed to test soil composition, moisture retention, and drainage before laying a single mat. They learned to spot danger signs: the dull shine of saturated clay, the bubbles that hinted at trapped air pockets, the subtle tremor underfoot that warned of collapse. What began as battlefield improvisation evolved into one of the earliest forms of combat geotechnical engineering. Within weeks, new hybrid runways sprang up across the archipelago, coral-based, bamboo-reinforced, and mat-covered. Locals nicknamed them singing roads because the hollow layers beneath produced a low hum when planes landed. Pilots joked they could tell what island they were on just by the sound of the runway under their tires. But for the men who built them, it was more than music. It was survival. As the engineers perfected the coral-laterite mix beneath their steel mats, word of their success spread like wildfire through the Pacific. Commanders who once cursed the endless rain now began to believe that nothing could stop American engineering. But even as the victories mounted, a new kind of problem began to surface, one that would push the limits of physics itself. It started when the engineers reached the island of Mindoro, where the soil was not just soft but alive. Beneath the upper layer of mud lay hidden veins of organic decay, old mangrove beds that exhaled methane and shifted with every vibration. When the first bulldozer rolled across, the ground literally breathed beneath its treads. The men watched in awe and fear as the earth pulsed, swallowing one of their trucks whole. The driver barely escaped before the mud closed over the cab like a mouth. Colonel Marston, now a legend among engineers, arrived within days. His once crisp uniform was permanently stained with the reddish dust of half a dozen islands. When he saw the sinking runway, he muttered, "This island's alive, and it doesn't want us here." But giving up wasn't an option. General MacArthur had ordered the airfield, operational in less than 72 hours, to support the invasion of Luzon. That meant finding a way to make steel float on breathing mud. The solution came from a quiet, soft-spoken sergeant named Joseph Hanley, a former construction worker from Louisiana's Bayou country. While others argued over measurements and material strength, Hanley stared at the shifting ground and smiled. "You're all trying to fight it," he said. "Back home, when the swamp moves, we move with it." He sketched something in the mud, a pattern of overlapping mats laid in alternating directions, like scales on a fish. Instead of forming rigid lanes, the runway would become flexible, able to rise and settle with the shifting earth. The engineers stared at him, skeptical but desperate enough to try. For the next 36 hours, they worked like men possessed. They laid double layers of mats, cross-hatched to distribute stress, then reinforced them with salvaged bamboo and netting. The structure wasn't pretty. It undulated slightly as men walked across it. But when they tested it, something remarkable happened. The more pressure they applied, the stronger it became. The trapped air and flexible underlay turned it into what Marston later described as a floating airfield. At dawn, the first P-51 Mustang approached. The pilot hesitated. The runway looked like it was rippling in the breeze, but command ordered him to land. As his wheels touched down, the runway flexed beneath him like a living thing, absorbing the impact. Dust and water sprayed, the mats clanked and groaned, but they held. The crowd watching from the tree line erupted in shouts and laughter. The floating field had worked. That day, they discovered something extraordinary about the Marston Mats. Their strength didn't only come from steel, it came from geometry. The perforations reduced suction, allowing air to escape from beneath, while the corrugations distributed pressure dynamically. It was a living system, not a static one. Marston realized that he hadn't just invented a portable runway, he'd stumbled upon a principle of adaptive design decades ahead of its time. Engineers across the Pacific began experimenting with new variations. Some laid triple layers to support bombers, others mixed coral with crushed volcanic rock. On the island of Leyte, one inventive crew used empty fuel drums as buoyant pillars beneath a strip of mats, creating an actual semi-floating airfield over a swamp. "We were building over quicksand with tin and prayers," one lieutenant laughed later, "and somehow it worked." By now, the legend of the men who paved the sky had grown so large that even the infantry spoke of them in awe. The airmen called them mud magicians. Pilots knew that every time they saw a gleaming steel runway below, it meant someone had conquered nature for them. But the men who laid those mats rarely got credit. They worked in the background, invisible, until the planes arrived. Their satisfaction came not from medals, but from the thunder of engines taking off safely into the dawn. Still, the work took a brutal toll. The tropical heat warped steel. Men suffered burns from touching sun-baked panels. Insects infested their food. Malaria stalked the camps. Yet even half delirious with fever, they kept building. When a shipment of mats arrived rusted and useless, they scrubbed them with sand and seawater until they gleamed again. "We didn't have the luxury of failure," one corporal wrote in his diary. Every hour we lost meant boys dying at the front. But as they pushed further into the Pacific, closer to Japan itself, the engineers faced a new kind of challenge. Not mud, not rain, but fire. Their steel mats, once their greatest weapon, would soon turn against them under a sky lit by flames. The island of Iwo Jima would test everything they'd learned and force them to reinvent their miracle all over again. The war was ending, but the sound of hammers still echoed across the Pacific. While cities fell silent and victory flags rose, American engineers were still at work, building, repairing, and maintaining the same runways that had carried the war to its end. The skies above Iwo Jima were filled with the thunder of returning bombers, many limping home on fumes and torn wings, each one searching for a miracle strip of steel shining faintly through volcanic ash. Beneath them, the Marston Mats, battered, scorched, dented, yet unbroken, lay like scars across the earth. They had seen everything: blood, fire, mud, rain, and victory. And now, as the last great battles faded into history, the men who built them stood in silence, watching the planes land one by one. They had changed the face of warfare, and they knew it. When U.S. forces stormed Iwo Jima in 1945, the air war over Japan reached its climax. The island was a fortress of volcanic rock, pitted with tunnels and sulfur vents that made construction nearly suicidal. Bulldozers bogged down in black sand so soft it swallowed entire machines. The air stank of sulfur and smoke from constant bombardment. Yet within days of securing the beachhead, engineers arrived with their crates of Marston Mats, ready to do the impossible once more. They laid steel over hellfire. The first runway at Motoyama was barely usable, buckled, uneven, and covered in ash, but it was enough for the crippled B-29 Dynamite, returning from Tokyo, to touch down safely. Its crew staggered out, falling to their knees, kissing the metal beneath them. For them, the war ended on a mat of steel laid by men they would never know. The engineers who built those runways rarely saw the glory of parades or medals. Their reward was survival, and the knowledge that every strip they built became a lifeline for others. On Iwo Jima, they worked 20 hours a day under shell fire. Japanese snipers targeted them from caves, yet they refused to stop. One lieutenant recalled shouting over the noise of machine guns, "Keep laying! The planes are coming!" And they did. They hammered, welded, and laid mats until the sky above them roared with friendly aircraft once again. When Japan surrendered months later, the same engineers found themselves dismantling what they had built, lifting Marston Mats piece by piece, cleaning them and preparing them for transport once more. But the world had changed. Where once those steel sheets were tools of war, they were now tools of rebuilding. Across Asia and the Pacific, U.S. forces repurposed them for roads, refugee camps, and hospitals. A mat that once launched a fighter jet could now serve as flooring in a field clinic, or as a bridge across a flooded river. Villagers salvaged leftover panels to build roofs, fences, and even boats. The legacy of the Marston Mat was no longer destruction, it was rebirth. As peacetime returned, the brilliance of the design began to inspire a new generation of engineers. Civilian airports in the 1950s studied Marston Mat construction to develop rapid deployment runways for remote regions. Oil companies used modified versions for drilling sites. The United Nations employed them for emergency relief airstrips in Africa and Asia. What had begun as a desperate wartime invention became a global blueprint for mobility and resilience. The phrase 48-hour runway entered engineering textbooks as a symbol of ingenuity under pressure. Colonel James D. Marston himself returned to a quiet life, teaching engineering at Auburn University. He never sought fame, but his students spoke of him with reverence. When asked about his invention, he would smile and say, "It wasn't the steel that won, it was the men who laid it." He understood that the true miracle of the Marston Mat wasn't its strength or its speed, but the spirit behind it, the belief that no challenge was too great if minds and hands worked as one. The mats, however, outlived even their maker. Decades later, explorers on Pacific Islands still found them half buried in jungle vines, rusted but intact. Locals used them as steps, fences, even as sacred memorials. On the island of Peleliu, a single strip of Marston Mat still gleams faintly in the morning sun, a relic of an age when men turned steel into salvation. Each dent tells a story of mud-choked nights, of sweat, of planes landing under gunfire, of hope. Historians often debate what single invention most influenced the outcome of the Pacific War. Some name the aircraft carrier, others the atomic bomb. But to the men who fought on those islands, the answer was simpler. It was the steel beneath their boots. The Marston Mat didn't just build airfields. It built victory. It allowed America's war machine to move faster, reach farther, and adapt to any terrain. It made islands into fortresses, jungles into highways, and swamps into launch pads. Even in the modern era, echoes of Marston's genius remain. The U.S. Air Force still uses updated versions of PSP, now called AM-2 Mats, for rapid airfield construction. Humanitarian missions use them to land aircraft in disaster zones where no infrastructure exists. Every time a plane touches down on a temporary runway somewhere in the world, a part of that moment traces back to those men in the jungle, hammering steel under rain and fire. As night falls over the forgotten islands of the Pacific, the old runways lie silent. The jungle creeps back, vines curling over rusted steel, reclaiming what was once torn from it. Yet beneath the moss and shadows, the Marston Mats remain, defiant, enduring, a testament to human will. Somewhere out there, a pilot still flies above those forgotten strips, unaware that beneath the canopy below lies the very metal that made his journey possible. The war ended long ago, but the story of those runways never did. Because as long as there are places the world calls impossible, there will be men and women ready to lay the first piece of steel and prove that nothing truly is.